All right, here we go, recording. So we're looking at specifically 572, that's the one we're focusing on. But 571 is kind of related to the review that I put over here. So we're talking about polygons and quadrilaterals. So has anybody ever ridden a ATV that has four wheels? What's that called? Four-wheeler. Four-wheeler. You call it a quad because it has how many wheels? Four. So quadrilateral, how many sides are we talking? Four. And there's 7 basic quadrilaterals. We're just going to break them down. Just like yesterday when we had relationships between parallel lines and transversal, if I know that those two angles are congruent, then I make whatever is in those angles, the expression, the numbers, whatever, I make them equal to each other. That exact same idea of looking at the shape and relating the sides or expressions is the same what we're going to do today. We're just going to be applying it to, say, a square, a rectangle, parallelogram, and all these over here. What happened with that? So just as the review, parallel lines have the same slope. They have the same slope. If this is my coordinate plane, which I'll just use like this, if I have a line that goes up to over 1, I have this line, right? Over here, if I start from this point and I go up to over 1, I have the same slope, and I should have, well, I should have some parallel lines. All right? So if you're going up to over 1, up to over 1, up to over 1, your steps are the same, right? So the lines that are created by those steps are going to be the same. So we can test if lines are parallel by looking at the slope, how far up and over it goes. Okay, so how about this? Are these two lines parallel? No. And if I was doing this on a coordinate grid, I'd be able to see that. I go, say, up 2 over 2. Here I would have to go, let's see, up 2 over 1, 2, 3 or so, right? So this one has a slope of 2 over 1, rise of 2, rise over 1, 2 over 1. And over here we have a rise of 2, a run of 3. So if the slopes are different, not parallel, okay? So with these shapes, if I know, we already know what a rectangle looks like, and on your sheet of 7 shapes, you could probably see real quick, you know, that's a rectangle. Opposite sides are parallel. That's what those tick marks mean. So if that's the case, then we look here and these lines better be parallel, and I would be able to actually count the slope for each of them and see if they are parallel. Okay, so with this idea, we can see if our shapes are true shapes, and we can figure out what kind of shape it is based on how the slopes relate to the sides. Okay, so I'll leave that up for a second. The distance formula isn't going to apply too much to this lesson, but I want you still to have it there. If you were trying to see that, you know, the sides of rectangles are congruent, so this length here is the same as that length. If you had the 2 points, you could figure out which one is x1, y1, which is x2, y2, and from that, you would be able to plug it into the distance formula and actually find this length. You would then do that over here too if you had to. So you'd find that distance, and they have to be the same. So this is the first review here is figuring out what kind of shape it is. But we're going to mainly for this lesson focus on what are these shapes, not in figuring them out from scratch. Okay? But if I gave you these points to graph, right? If I gave you some points to graph, you graph those points, you could find the shape from that, right? You can find the shape from that because we're going to learn all the different details for each of the shapes. Okay, so now go ahead and turn to the page that has your 8 different boxes kind of situated. And what I'm going to do is I'm going to call out some clues about each of the shapes, and we're going to figure out which one is which. Some of these you guys already know. You've seen them before. Some you don't. Okay. So get that out. Go ahead and have your sheet out that has the 7 different polygons. So I have all that out and ready to go. And here we go. All right. I want you to look at those polygons, and I want you to find the one that, let's see. How about find the one that has bases and legs? You see the one that maybe has base? We have some identified as the base, some identified as the legs. Okay. So how many kinds of trapezoids do we have? Two. One of them is an isosceles trapezoid, the other is a regular trapezoid. But we know that for both of those, they have what? Base and legs. So base and legs, you can write over everything. Base and legs. Okay. Let's see, I want you to find the one that matches these two things. They have base and legs, but also that they're in a regular shape. They're in a regular shape. Which one are we looking at then? So look at your list of them. So I know that they have bases and legs. That's isolated to trapezoid or isosceles trapezoid. Which one has an irregular shape to it? What do you think? So look at your shapes. You have no way to know unless you're looking at this and looking to see which one of those two options, the ones with the base or the legs, which one is more of an irregular shape? All right, so I want you to go ahead and this trapezoid has legs on the outside and it has a base and a base. Isosceles trapezoid is not irregular because it has so many things in common. It has, so I want you to go ahead and identify on your little half sheet. Go ahead and put trapezoid above the one up there at the regular. You can also jot these little piece of information next to it. Although looking at that diagram, you can also just see that these are there by the tick marks. So isosceles triangle has base angles that are the same. It has the other angles also congruent. We have diagonals that are congruent. And the legs are congruent. Also, the bases are perpendicular, parallel to each other. Base, base, leg, leg. Not legs, that's legs. Okay, so the way you would approach a problem like this, if you were told that this base angle over here was, let's see, 2x plus 10, and this base angle over here was, let's just go with 70 degrees. If I told you to find x, what could you do with those two expressions? You know this angle over here is 70. You know this one is 2x plus 10. What should I do with those values? We do what? Plug them in where? We don't have anything quite yet to plug in. If I just wanted to know the angle measure of this, what does this tick mark align with? This tick mark with this corner, saying that those two are exactly the same. Remember, the tick marks tell us what's the same. So if this is 70, this would be 70 as well. You agree with that? Okay, the tick marks tell you that. So if I have an expression related to this corner over here, this angle, then I'm going to go ahead and make them equal to each other, because this angle is equal to this. So I don't care what it is. Whatever is identified either as an expression or value for that angle, it has to be equal to the other one. So that's why 70 is equal to 2x plus 10. You see, it's the same kind of problem. Just like when we had alternate interior, we knew they were the same. So whatever values are in those, we made them equal to each other. It's the exact same thing. We just have different shapes, different versions here. So we work that out, and we would get x is 30. We subtract 10, we divide by 2. We get down to x is 30. Okay. Let's see. The next clue is, let's see, which one has no parallel sides? Look at the tick marks. You have to identify those tick marks. I'm looking and I see that parallel sides. Which one has no parallel sides? So is it first row or second row? Which has no parallel rows? Second row, so then we're looking at isosceles trapezoid. This one's called a kite. This one's a parallelogram. So which one then? The kite has no parallel lines. No parallel lines right there. So I'm going to go ahead and bring, the kite looks like those old school, you know, Benjamin Franklin being a wild person and flying a kite in a thunderstorm, lightning storm. All right, so we have our kite right here. We know that the kite has no parallel lines. We know that it also, the diagonals make a right angle. Our diagonals meet at a right angle. And the last one is that it has that right angle, so we'll leave it at that. That's good. That's mainly it. So again, how I would approach this if I needed to, if this was equal to 12, and this is equal to x plus 2, what do I know about those sides? And how do you know it? What's this tick mark tell us? This is equal to what? Congruent to? The other one. The other place that has one tick mark. So this is 12. This is x plus 2. So what I would do with that is 12 is equal to x plus 2. So x is 10. You see again, you look to the sides. Does the shape say that they're congruent? They are. So I'm going to relate the sides in the same exact way. Okay. Let's see. How about identify the shape? Not even by the name yet. Just identify the shape that has all sides are congruent. All sides are congruent. Which one shows that all the sides are congruent to each other? Square. Is there another one? Okay, so top row. Top row, we got the square. Remember, the square has all congruent sides. We already kind of knew that. This rhombus has all sides. And I think of a rhombus. This rhombus is actually just a squish square. The rhombus is a squish square. So of those two, which one has all right angles? Square. All right, so square, obviously all the sides are the same. Right angles, these diagonals are also the same. And the diagonals meet at a right angle. But you might just write on top of your square because that's what you can use to access it. Okay, so everybody also writing on the half sheet, go ahead and write each of these. And yeah, square has right angles, opposite sides, congruent. We have diagonals right at right angles. And all sides congruent. All sides congruent. Okay. Let's see.
Just repeat what's the third one.
Diagonals at right angles. The diagonals meet at a right angle. All right, how about this? I want you to look at the shape. Tell me the one that has all right angles. All right angles. Also has opposite sides that are parallel. It has opposite sides that are congruent, that are the same. And the diagonals are congruent to each other. Which one met all those options that we have left? What do we have left here? Yeah. So which one do you think that was? Rectangle. So again, we had all right angles. We had they're parallel to each other, opposite sides. So you don't have to redraw the shape because you already have it. We have opposite sides are congruent, diagonals are congruent. So let's just put a couple of those. We got right angles, opposite sides congruent. And we know that diagonals are congruent. All right. This one over here. Okay, of the two left here, which one has all sides are congruent? All sides are the same. What do you think for that one? All sides are the same. Rhombus. I like to think of a rhombus as just a squish square. It's just a squish square. So you take a square and it's also a diamond. We end up with all these situations. We know that these are the same as that. That's the same as that. And they meet at a right angle. So let's see, all sides congruent. Let's see, opposite angles are congruent. Diagonals meet at right angle. That's good. All right, the very last one, parallelogram. This one basically is just, basically has opposite sides parallel and congruent. Opposite angles, congruent. And the diagonals are cut in half. So you don't have to rewrite that, you already have the shape. You just got to, on the shape here, put parallelogram next to it. So make sure you're updating your sheet with all your 7 different quadrilaterals. And let's just break down what this has here. We have opposite sides and angles are congruent. And let's see, you could say diagonals bisect each other. They cut each other in half. And we could say opposite sides are parallel. Okay. So that is actually it for our 7 shapes. Now again, just to kind of elaborate how this might work out. If I'm told that this angle right here in the square, this angle right here is equal to 5x plus 10. Right? How could I find what x is? First off, it's pointed to this angle right here. What do we know about that angle? What do we know? What does that box shape tell us? It's a right angle. So I know it's 90 degrees. So if 90 degrees, that angle has this expression to it, 5x plus 10. I know that that's 90 degrees, so what I would do is I take 90 and make it equal to 5x plus 10. Right? Because you know something about the angle, you're, again, all the geometry is relating the expression or value to an angle in the same way that these rules tell us. So 90 is equal to 5x plus 10. I'm going to subtract 10. 80 is equal to 5x. X is equal to 16. All right. It's really the same as alternary angle, corresponding angle, all those rules we learned yesterday. All right, it's all the same. So those are the type of problems we're going to face. We'll also be given some points that we have to figure out what kind of shape the points make. You're going to use all these guidelines, and just the tick marks should help you. So if I end up with a shape like this, what shape would that work with? Let's see. Definitely not a rectangle, not a square, not a parallelogram because the sides aren't parallel to each other, not a kite, close. It's close, but those sides aren't the same. Now the trap, isosceles trap, it looks more like a regular trapezoid. Because we have a base, we have legs, or you can look at it the other way too. Okay? So, again, this is going to be a lesson that applies, and it's going to help you with yesterday as well. So plugging in and just working out what those angles are. I'll have that video up tomorrow, probably by 5th. I'll do it in 5th. I'll try to make it funny. We'll see how it goes. All right, so you guys just have the 5.7.2 assignment here. It's a short assignment. You can get it done in class, so let's go ahead and work on that. Again, if you haven't subscribed, I only have 101 subscribers. 22 more until someone gets some Oreos. Waiting. All right, subscribe. Have a good one.